Welcome to a special crossover episode of Bare Metal Cyber and Trackpads, where I'm going to blend the worlds of cybersecurity and the military, two fields that are deeply connected in ways you might not expect. Today we're focusing on artificial intelligence, or AI, and its growing impact on modern warfare. We'll discuss how AI in the civilian world translates into military applications, provide a quick historical context, and then break down current uses, ethical challenges, and future outlooks. Let's begin by setting the stage. In our daily lives, AI powers everything from social media feeds and personal voice assistants to advanced recommendation algorithms on streaming services. The same technology that curates your music playlist or optimizes your online shopping experience is also being adapted to strategic military missions. But how did we get there? AI in the civilian world versus military applications. The civilian world and the military have often shared parallel tracks of technological development. Historically, innovations like the internet, GPS, and certain forms of robotics had their origins in defense-related research before eventually becoming mainstream. Today, however, we see sort of a bidirectional flow. Major tech companies, academia, and the military are collaborating in ways that sometimes blur the lines between civilian and defense research and development. Civilian AI focuses on commercial applications, user engagement, data analytics for businesses, personalized services, and problem-solving in areas like healthcare and finance. For instance, a hospital might use AI-driven imaging systems to diagnose diseases more accurately, while a bank employs AI for fraud detection. Military AI, however, emphasizes strategic advantage, threat detection, mission efficiency, and battlefield situational awareness. For example, advanced computer vision might analyze real-time drone footage to identify potential targets or suspicious movements. Naturally, some of these commercial and military objectives overlap. If AI can identify a tumor in a medical scan, it can also identify a tank on a battlefield. This dual-use nature of AI, where the same code base could be used for either civilian or military tasks, makes it both powerful and ethically fraught. Let's give some historical context. Past examples of automation in warfare. AI in the strict sense may be relatively new, but the idea of automation aiding warfare goes back decades. Here's a quick recap. In World War II, early automated devices like the Enigma machine and the Allied code-breaking efforts at Bletchley Park might be considered preludes to the modern digital revolution. Alan Turing's ingenious work on code-breaking laid foundational concepts in computer science. In the Cold War era, automation took the form of rudimentary computerized guidance systems for missiles. Basic pattern recognition helped track objects, though the technology was nowhere near as sophisticated as today. In the late 20th century, precision-guided munitions and surveillance satellites became more common, with embedded computer systems to automate tasks like target acquisition and navigation. Although these systems weren't AI in the modern sense, they introduced the concept of delegating critical tasks to machines. Fast forward to the 21st century, and we're now seeing leaps in machine learning. Algorithms that can adapt and learn from data, enabling everything from facial recognition to predicting cyber attacks. This level of sophistication was practically unthinkable a few decades ago. Let's discuss some current AI-driven applications. And now that we have some background, let's talk about how it's used in contemporary military settings. Several prominent examples stand out, such as drones and autonomous vehicles. Perhaps the most visible manifestation of AI in warfare is the use of unmanned systems, especially drones. Traditionally, drones were remotely piloted by humans. However, as AI improves, the push for autonomy grows. Aerial drones can conduct surveillance, reconnaissance, and even carry out precision strikes. Advanced image recognition software helps them identify targets or suspicious activity with minimal human input. Ground vehicles, such as autonomous or semi-autonomous tanks and transport vehicles, could reduce soldier casualties by performing high-risk missions in conflict zones. So why does AI matter here? Because it grants machines the ability to operate with reduced human guidance, allowing faster decision-making. AI-driven vehicles may navigate rugged terrain using sensors and predictive models, or even coordinate with other machines to execute a multi-pronged mission. Intelligence, surveillance, and reconnaissance (ISR) form the backbone of most military operations. AI can crunch massive amounts of data, satellite imagery, drone footage, intercepted communications, and detect patterns that might elude human analysts. So let's discuss 3 examples. Computer vision. Advanced image recognition can spot unusual movements, identify vehicles, and track individuals. Some systems can even interpret body language cues or detect changes in topography that hint at hidden installations. Facial recognition. Although controversial, it is used in various scenarios, like border security checkpoints or to track high-value targets. And audio and signal processing. AI can sift through thousands of intercepted communications to flag keywords or anomalies. This capacity to handle big data is critical in modern warfare, where intelligence can mean the difference between a successful mission and a catastrophic failure. By automating data analysis, militaries can act faster, sometimes within seconds, on information that would take a human team hours or days to interpret. Decision support, data analysis, and predictive modeling. The sheer volume of information available to modern militaries is staggering. Consider everything from historical battle data and satellite imagery to troop movements and real-time weather patterns. Human commanders can't possibly process all of it. AI algorithms excel at finding relationships and correlations in such data. By analyzing data from aircraft, ships, or tanks, AI can predict mechanical failures before they happen, reducing downtime and saving costs. AI can also optimize the flow of equipment, food, and other resources to the front lines. And with battlefield forecasting, predictive models might gauge enemy movements or the likelihood of certain attacks, enabling proactive defense strategies. AI-driven decision support tools can essentially act as force multipliers, enabling a smaller force to do more with less. However, this also raises questions about how reliant militaries become on automated recommendations, especially in fluid and unpredictable combat environments. So let's talk about the ethical and strategic considerations. The growing adoption of AI in militaries worldwide isn't just about technological prowess. It also opens the door to serious moral, strategic, and political questions. Let's look at some key issues. First, concerns about autonomy and lethal decision-making. One of the most hotly debated topics is the idea of killer robots, fully autonomous weapon systems capable of making life or death decisions without human intervention. While many militaries stress that a human is always in the loop, the line between supervised autonomy and full autonomy can get blurry. Such as responsibility. If an autonomous system kills civilians by mistake, who is held accountable? The commanding officer, the software engineer, or the AI itself? Escalation risks. Automated systems can react at machine speed, accelerating conflicts to a point where human diplomacy or de-escalation lags behind. And ethical frameworks. International efforts exist to regulate lethal autonomous weapon systems, but global consensus is far from reached. Concerns around how to incorporate concepts like mercy, empathy, and context remain unanswered when it comes to AI-driven decisions. Human oversight and accountability. Even if we don't reach the scenario of fully autonomous weapons, AI-driven decision-making introduces complexities about oversight, like black box issues. Many advanced AI models, such as neural networks, are not easily interpretable, making it difficult for humans to understand how a machine arrived at a conclusion or a recommendation. Automation bias. Humans may overtrust machine outputs, believing AI is more accurate than it might actually be, especially under stress in battlefield conditions. And training data bias. AI systems are only as good as the data they're trained on. Biased or incomplete datasets could lead to flawed targeting or discriminatory profiling. Militaries worldwide are grappling with how to insert appropriate checkpoints so that any AI-driven action can be audited. Some propose mandatory human-in-the-loop protocols, where a person must approve any lethal action. Others envision an augmented approach, where AI handles the data crunching but final decisions rest with human commanders. Yet as technology evolves, maintaining strict oversight may become increasingly challenging. So what is the future outlook of AI? How might AI evolve in military contexts over the coming years, and which countries are leading the way? Let's explore some possibilities and the competitive global landscape. The evolution of AI in military contexts, such as adaptive learning systems. Future AI might be able to continuously learn from real-time events during a conflict. An AI system observing enemy tactics could update its models on the fly, becoming more accurate and lethal with every mission. Swarm intelligence. We might see fleets of drones or robots that coordinate using AI-driven swarm intelligence. This means hundreds or even thousands of small, low-cost units acting in concert to overwhelm defenses. Cognitive electronic warfare. Electronic warfare systems that use AI to jam or spoof enemy sensors, radar, or communications in a highly adaptive manner could become crucial. Over the long term, we may reach a point where AI systems are so tightly integrated into every aspect of military hardware and strategy that they become the invisible backbone of defense operations, much like the internet is for modern communications. Let's discuss some key global players and their AI initiatives. AI is not the domain of any single nation. Several major powers are competing or collaborating in the AI arms race. With the United States, historically a leader in both AI research and military innovation, the U.S. Department of Defense has multiple initiatives such as the Joint Artificial Intelligence Center, focusing on integrating AI across all branches of the military. Major tech companies like Google, Microsoft, and Amazon often partner with government agencies for research and development, though these partnerships sometimes spark controversy among employees and the public. With China has declared AI a national priority, with ambitions to become the world leader in AI by the early 2030s. Companies like Baidu, Alibaba, and Tencent invest heavily in AI research. The Chinese military is closely connected to these tech giants under the concept of civil-military fusion, blurring the line between civilian and tech defense in China. Russia, another key player aiming to modernize its military capabilities with AI-driven technologies, particularly in the autonomous weapon systems, cyber warfare, and electronic warfare domains. Russia has demonstrated advanced capabilities in hacking and disinformation campaigns, which AI could further enhance. European nations, countries like the UK, France, and Germany are also investing in AI for defense, albeit sometimes in more regulated frameworks, placing emphasis on ethical guidelines and NATO cooperation. And other countries around the world, such as Israel, India, and South Korea, are examples of countries with robust tech sectors and strategic interests that are also building AI capabilities for defense. This competition can spur rapid innovation, but it also stokes fears of an AI arms race reminiscent of the nuclear arms race during the Cold War, where nations might prioritize speed over caution or ethical restraint. In conclusion, artificial intelligence is undeniably reshaping modern warfare. From drones and autonomous vehicles to advanced surveillance and decision support tools, AI's capacity for rapid data processing and pattern recognition offers militaries unprecedented capabilities. However, with these advancements come ethical and strategic dilemmas. The potential for fully autonomous weapons raises concerns about accountability and humanitarian law. Reliance on black box algorithms can undermine trust and oversight, and the global race for AI supremacy may escalate tensions among major powers. So what can we expect in the near future? Further integration of AI into everyday military operations, a continuing arms race among the world's leading powers, and ongoing debates about how to regulate or limit lethal autonomous systems. Commanders and policymakers will need to ensure that the development of AI is balanced with transparent ethical standards, robust oversight, and an awareness of unintended consequences. So where do you fit in? As citizens, taxpayers, and tech innovators, or just global observers, we have a stake in how AI is developed and deployed. Increased public dialogue, policy discussions, and cross-border cooperation in setting norms will be vital to making sure that AI in warfare remains under human control and used responsibly. And that's a wrap for today's crossover between bare metal, cyber, and trackpads. Be sure to check out our regular episodes for more deep dives into cybersecurity and military stories. For more stories, check out the Bare Metal Cyber and Trackpads newsletters and podcasts at newsletter.baremetalcyber.com or newsletter.trackpads.com. And of course, visit all of my books at cyberauthor.me. Thanks for listening.